Okay, good morning, everyone. Okay, so I was not able to meet you earlier because akong charger sa laptop is wala, no? So I am recording this video para sa klase nato for today. So I hope you will watch the entire video. Okay. So um ang ato tuod topic for finals will start sa Unit 5 to Unit 7. So basically karon this first three topics nga akong i-discuss today, muna siya ang sugid sa atong finals. And by the way, your result sa inyong exam is pwede ninyo makuha diri sa school sa Thursday o Friday. So kung dili niyo makuha karon, pwede rin ninyo kuha on this January pagbalik sa classes. So mag face-to-face classes ta start sa January. Na mag-ingon na po ko sa schedule. Ang schedule sa ato ang face-to-face classes is kuan ni once a week lang. So every week mag face-to-face tapos mag-online ta sa katong other day nga dili ta mag face-to-face. Kay gamay ra man atong rooms, dili na to ma-occupy ang uban rooms or atong i-occupy lang is katong assigned sa ato ang mga rooms. Okay. So without further ado, mag-start na ta no. Okay, so Unit 5 is the mathematics of graphs. Okay. So, but before that, let us, wait lang. Let us know the brief history of mathematics of graphs. Okay, the mathematics of graphs focuses on the creation of models that represent real-world contexts involving networks and graphs. So let us watch a short clip on how the graph theory was born before we proceed. So
You'd have a hard time finding Königsberg on any modern maps, but one particular quirk in its geography has made it one of the most famous cities. You'd have a hard time finding Königsberg on any modern maps, but one particular quirk in its geography has made it one of the most famous cities in mathematics. The medieval German city lay on both sides of the Pregel River. At the center were two large islands. The two islands were connected to each other and to the riverbanks by 7 bridges. Carl Gottlieb Euler, a mathematician who later became the mayor of a nearby town, grew obsessed with these islands and bridges. He kept coming back to a single question: which route would allow someone to cross all 7 bridges without crossing any of them more than once? Think about it for a moment. Give up? You should. It's not possible. But attempting to explain why led famous mathematician Leonard Euler to invent a new field of mathematics. Carl wrote to Euler for help with the problem. Euler first dismissed the question as having nothing to do with math, but the more he wrestled with it, the more it seemed there might be something there after all. The answer he came up with had to do with a type of geometry that did not quite exist yet, what he called the geometry of position, now known as graph theory. Euler's first insight was that the route taken between entering an island or a riverbank and leaving it didn't actually matter. Thus, the map could be simplified, with each of the four landmasses represented as a single point, what we now call a node, with lines or edges between them to represent the bridges. And this simplified graph allows us to easily count the degrees of each node. That's the number of bridges each landmass touches. Why do the degrees matter? Well, according to the rules of the challenge, once travelers arrive onto a landmass by one bridge, they would have to leave it via a different bridge. In other words, the bridges leading to and from each node on any route must occur in distinct pairs, meaning that the number of bridges touching each landmass visited must be even. The only possible exceptions would be the locations of the beginning and end of the walk. Looking at the graph, it becomes apparent that all four nodes have an odd degree. So no matter which path is chosen, at some point, a bridge will have to be crossed twice. Euler used this proof to formulate a general theory that applies to all graphs with two or more nodes. A Eulerian path that visits each edge only once is only possible in one of two scenarios. The first is when there are exactly two nodes of odd degree, meaning all the rest are even. There, the starting point is one of the odd nodes, and the endpoint is the other.
Okay.
The second is when all the nodes are of even degree. Then, the Eulerian path will
Okay, so di na nato. Dito lang ta sa history niya, no? So, mo to siya yung history tungod sa iceberg problem. So, which is not possible, di ba? Okay, so, kato si Gottlieb Euler, okay, which is a mayor sa neighboring nga city daw. Nagpatabang kang Leonard Euler, which also is a mathematician. And mo na rin to, nakadiscover na siya or nag-invent siya og bagong nga field sa mathematics, which is the geometry of position, or it is called graph theory in the modern days. Okay, balik ta. Okay, so later on, katong explanation is answer to na to or makita to na to later sa ato ang topic, which is Eulerian graphs. Okay, so si Leonard Euler, which is a Swiss mathematician, solved the problem, or instead of solving the problem, iyahang gi-explain nganong dili possible to nga problem. So his solution was published in 1736 and may be the first to use the graph theory. So naa siya paper on 7 bridges of Iceberg. Okay, so mo ni siyang Iceberg, no? So in simpler kanang pagka-draw, pwede nga ani. So in graph, pwede na to siya i-model as this one. Okay, so there are also several uses of graph theory. One of which is kining Hamiltonian graphs. Okay, si William Hamilton pod ang nagpasiugdaan ni. So it's because sa iyahang Icosian game. So ang iyang Icosian game is a mathematical game invented in 1857 by William Rowan Hamilton. So the game's objective is finding a Hamiltonian cycle along the edges of a dodecahedron. So dodecahedron is mura siya cube nga 12 faces, no? Okay, dodecahedron, so naka 12 faces. Okay, such that kada edge daw is imuhang ma-visit. So kani, diri, kana, imuha daw nang ma-visit tanan, kana. So, dili pwede nga balikan nimo siya. So, dapat ma-visit nimo single time, tapos no edge is visited twice, and the ending point is the same as the starting point. So, dapat magsugod daw ka and mag-start sa the same nga point. Okay, so we also have trees in electric circuits. So we can also model electric circuits using graphs. Okay, we also have enumeration of chemical isomers. So instead of this, pwede na to drawing on like this, which is also a graph. Okay, we also have 4 colors of maps. So later on, makabalo mo na tayo graph coloring. So application ana niya is coloring sa maps, no? Nga dapat walay magtapad ng parehag color. Ana. Okay, we also have commonly known applications of graph theory. We have transportation networks, internets, and we also have genetic interaction network and ecological networks. Okay, so let's have the basic terms in graph theory. Basic terminologies or basic terms in graph theory. Okay. So at the end of the lesson, you should be able to represent real-life situations into diagrams called graphs. So define and illustrate the basic terminologies in graphs. So many real-world situations can conveniently be described by means of a diagram consisting of a set of points together with lines joining certain pairs of these points. So we begin by considering figure 5, this figure and this figure. So this figure is a park map. So, kini siya mga dalan sa park. And this one is an electrical network. So, pwede na nato siya ma-model using a graph. Okay, so either of these situations can be represented diagrammatically by means of the points and lines. So, ang points, pwede na to himuag diagram ni kining sa park map, which is ang kaning mga points is kaning mga murag intersection sa mga dalan or um, mga tumoy-tumoy kana, no? So, we have this one and pwede po kini siya is pwede po nato siya ma-model like this. Okay. So, the points P, Q, R, S, and T are called the vertices of the graph, and kining mga lines connecting them are the edges of the graph. Again, vertices are the points. The lines joining the vertices are called the edges. Okay, so take note nga for this diagram tanawa kani siya wala siya nagtagbo, wala siya nag-intersect. Siguro kining isa is nani siya sa ibabaw nga dalan and kini nasa ubos, so wala sila intersection. And this one for electrical network, siguro kaning nga wire wala gid sila nag-join, no? So kuan siya, patong lang siya. So mo nang wala daw vertex between PS and QT. So since it does not correspond to an end of the crossroads of meeting the two wires. Okay, so this is the formal definition of a graph. A graph G is a pair V of G, E of G, where V of G is a non-empty set of elements called the vertices, and E of G is a family of two element subsets of VG called the edges. So a graph will contain a vertex and an edge, so or edges. So pero pwede ra pod ang graph is vertex lang siya. No, pwede ra point. It's still a graph. Okay, so ang VG man daw is non-empty subsets of elements called the vertices. Ang E of G is a family of two element subsets. O siya naingon nga ang E of G is kanang dili siya non-empty. So the set VG is called the vertex set of G, and the set E of G is called the edge set of G. So to illustrate, it is customary to represent a graph by means of a diagram or drawing. So each vertex is indicated by a point, and each edge is by a line or an arc joining the points that represent the ends. Okay, there is no unique way of drawing a graph. The relative positions of points representing vertices, lines represents edges, have no significance. So, ingon ani na siya class, ang graph is consist of vertices and points. So, ang vertices katong points, ang edges is katong line. Pero pwede pod nga kaning curve siya instead of a line, no? Or arc instead of a line. So, dili siya stricto nga line gid siya, no? Ang edge basta kay nag-join siya sa mga vertices. So, and ang pag-draw pod og graph is dili unique. So, pwede akong pagka-drawing sa graph is different sa imuha as long as it contains the same vertices and the same edges. So, let's have an example. So, let G be a graph where V of G is the set containing A, B, C, D, and E. So, as you can see, na kay vertices nga A, B, C, D, and E. Tapos, yun siya, ang edge set daw na to contains AB. So, pasabot na ay connection between kang AB, sunod EA, ED, DB, DC, and BC. So, nga nung ingon siya, ang pag-draw daw sa graph is dili siya unique. So, pwede man gud ingon ani akong pagka-drawing. So, for example, diri si A na ako gibutang, diri na ako gibutang si E, tapos diri si B, diri si C, and diri si D, no? Okay. So, sakto na, nanay lima ka vertices si A, B, C, D, and E, no? Then, niingon siya nga naa daw kang A o B. So, pwede na nako i-join diri A, B, sunod, EA, so this one, tapos ED, this one, tapos DB, kani, tapos DC, kani, tapos BC, kani. So, pwede nga kini nga graph and this graph and also this graph is just the same ra ni siya nga graph. Lahi-lahi lang pagka-drawing. So, dili unique ang pag-draw sa isa ka graph. So, this graph and this graph are equivalent graphs ni sila. Kay pareha silang vertex set, pareha po silang edge set. Okay, so again, dili unique ang pagka-drawing sa graph. Okay, for simplicity, we may write an edge as UV. So if E is equal to UV is an edge in G, we say that U and V are adjacent vertices or adjacent vertices. Okay, adjacent sila pag gi-connect sila og isa ka edge or more. No? Basta connected sila by an edge. So they are adjacent vertices. So for example, we have A and B are adjacent. Kay naaman sila connection. This one. Kinino, mo man na ilang connection. So, they are adjacent. Kinsa paylain connected kang A. So, si A is also adjacent to E. And kang B. Dili siya adjacent kang D o kang C because walay connection or walay edge connecting D and A and also A and C. So, adjacent, pasabot na siya connection silang duha. Okay, so, naputi gitawag nga incident. When you say incident, ang atong kuan gi-describe is ang edge ug ang vertex. Incident sila with each other if they are connected gihapon or kaha. Si edge is nakakonect siya kang vertex. So for example, vertex A and edge AB, mao man ni siya si vertex A, tapos mao ni siya si edge AB. So pasabot, si vertex A and edge AB are incident with each other. Kay connected silang duha. So pag edge o vertex imuhang i-describe na connected, they are incident with each other. Pag ang cross vertices imong i-describe as kanang connected silang duha, ang tawag ana is adjacent vertices. Okay? So I hope nasabtan. Okay. So let's now move on to the degree of a vertex. So let V be a vertex of graph G. The degree of vertex V, deg of V, is the number of edges connected with that vertex as an end vertex. So pasabutan ang degree sa kada vertex. Again, remember, ang vertex is katong points. So, ang degree niya is pila kabuok ang incident nga edge sa iyaha. Pila kabuok nakakonect nga edge sa iyaha. So for A, we have 1, 2, 3, 4. So ang degree ni A is 4. Tang B, naman nakabutang pila kabuok? 1, 2, 3, 4. So 4 ang degree ni B. Si C is 1, 2. That's why duha ang degree ni C. And si D, we have 1, 2, 3, 4, 5. So 5 ang degree ni D. Si E is 1, 2, 3. Ang iyahang degree is 3. And si F is 1, 2, 3, 4. So iyahang degree is 4. So mo ni iyahang giingon. A degree of A is 4, degree of B is 4, degree of C is 2, degree of D is 5, degree of E is 3, and degree of F is 4. Okay? Okay, so remark, in other books, the term graph defined in definition 5.1.1 is often called a simple graph. Katang definition nato sa graph kanina, this one. Okay, so in other books, this is referred as simple graph. So unsa man ang simple graph? Ang simple graph is kanang wala nag-contain og multiple edges and self-loops. Okay, multiple edges is kini siya pasabot given two vertices. Pag naay nag-connect sa iya og more than one ka-edge, ang tawag ana is multiple edges. Okay, excuse me. So, mo na siya. This is an example of a multiple edge. This one, si 1 ug si 2 gi-connect og duha ka edge. So, ang tawag ani is multiple edges. Okay, kini pod, si 2 ug si 3, since gi-connect man siya duha ka edge, no? Naapad diri sila connection, napagid sila diri. So, this is also called a multiple edge or multiple edges. Okay, ang self-loop is kanang naay edge nga nag-connect sa imo ni balik ra gyapon sa imuha. So this one is an example of self-loop. Duha pagid kabuk ang self-loop niya, no? Kaning sa vertex number 4 and also diri kang 3 na po siya self-loop. Okay, nasabtan we have multiple edges and self-loop. Okay, so ang simple graph is dapat wala siya multiple edge and wala po siya self-loop. Okay, pag imuhang graph mag-contain og multiple edges, ang tawag sa iya is multi-graph. Pag imong graph is mag-contain og multiple edges, mag-contain pagid siya og self-loops or loops, ang tawag sa iya is pseudograph. So the diagram given in this figure and this figure is an example of kini siya is an example of multigraph and this one is an example of pseudograph kay na siya loop na pagid siya multiple edges diri so 1 ug sa 3. So this is called a pseudograph. Okay, so these are examples of simple graphs without multiple edges and self-loops. So wala na siya multiple edges, no? Kay kana siya naka-connect man dira. Wala lain connection between them. And this one, wala ay multiple loops. Again, multiple loops. Multiple edges katong na ay nag-connect more than one edge sa duha ka vertex. So also here and here. So these are examples of simple graph. Okay, so a graph G is connected if every pair of points can be joined by an edge. Otherwise, you say G is disconnected. Okay, so sa Bisaya pa, or in other words, connected walay putol. So, iyang definition, if magikan daw ka sa isa ka vertex, malocate nimo ang other vertex or ma-join siya by an edge. Every pair of points can be joined by an edge. So, for example, kini kay 1, malocate niya si 2, pwede na siya moagi diri. And locate niya si 3, pwede siya moagi diri. Si 4, pwede siya moagi kang 5, matudan siya kang 4. Si 5, pwede siya diretso dira, no? Si 6, pwede po diretso dira. So bisan asa siya moadto makaadto gid siya kay naa may mga connections, no? So walay putol. And this one is disconnected. So kay dili man niya maadtuan tanan vertices given ang isa ka vertex, no? So example diri ko akong illocate ni. So moagi ko diri, agi ko diri, agi. Dili na ko katabok dito ko wala may tulay dito, no? So dili na siya connected. So this is an example of a disconnected graph. So sa Bisaya pa na ay putol, no? Okay. Okay, next is Euler graph. Okay. Okay, so Euler graph na po. Okay, this is read as Euler graph. Dili siya Euler class ha. Euler. Kuha na lang sa ko. Wala lagi ko yung video. Wait lang class ha. Siya nagsiga. Okay, so balik ta. Okay, so again, si Leonard Euler, which is Swiss mathematician, iya man tong gi-explain ang katong nganong dili ni nato ma-solve ning um kon iceberg problem or nganong dili possible nga agian nimo tanan bridges exactly once, no? Okay, so he had this definition. We have the Euler path, a path using every edge of the graph G exactly once. Meaning, agian daw nato tanan edge exactly once. So, man ang edge katong mga lines. No? Exactly once. Dili ka, pwede mo balik. So, ang Euler circuit is kanang agian daw nimo tanan ang iyang ingon no Euler path that returns to its start. Sabot agian nimo tanan edge but mag-start ka og mag-end sa the same nga vertex. Or kung aha ka nagsugod dito ka mag-end. Basta maagian nimo tanan ang edge exactly once. And Eulerian ang tawag sa imong graph if makakita kag Euler circuit ana niya. Okay, so for example, given the graph below, can you matabunan sa kong naong, no? Can you pass each edge? Kaya ako sang kuan. Can you pass each edge exactly once that begins and ends at the same vertex? So again, ang kanang points mo ng vertex ang edge kana. So agian daw nato tanan, no? Possible ba? So let's try. So sugod ta kang A. So kung moagi ko kang A, okay, dira no. This one. Okay, moagi ko dira. Padulong kay C, padulong kang E, padulong kang D. Wala pa ko nibalik ha. D, padulong kang C, C, padulong kang B, and then B, padulong kang A. So, naagian ako tanan, tapos nag-start o nag-end ko sa the same nga vertex. Unsa kong agianan? A, E, D, C, B. No? So, pwede po ka bisan na ka mag-start as long as makakita ka og Euler circuit. Ang tawag ani is an Eulerian graph. Since this is an Euler circuit, nakakita tag Euler circuit, pasabot kini nga graph is an Eulerian graph. No? So this is an example of an Eulerian graph. Okay, nasabtan. Okay, so naa daw siya Euler Circuit. Yes. Okay, so na siya theorem si Euler dire na ang connected graph G is Eulerian if and only if the degree of each vertex is even. Okay, the degree of each vertex is given. Saan tabunan akong face? Okay, so again, a connected graph G is Eulerian if and only if the degree of each vertex G is even. So kung even daw tanan degree sa vertex class, automatic Eulerian na siya. Di nakakinahanglan mag-trial and error dira og pangita og Euler circuit para maka makaingon ka nga Eulerian siya. So let's try to check if this is an Eulerian graph. Okay. So kini siya. Unsa itong degree, pila ka buok ang number of edges nga nakakonect sa iya or incident sa iya. Kang H na atay 1, 2. So ang degree ni H is 2. Si A 1, 2, 3, 4. So ang degree ni A is 4. Si B pod iyahang degree is 4. Si C is also 4. Si D is 4. Si E is also 4. Si F kay na ay 1, 2. Si G kay na ay 1, 2. So this is an Eulerian circuit. Eulerian graph. Kay nakakita, kay tanan niya element, tanan vertex niya is even ang degree. So this is an Eulerian graph. Okay, this one, diri at 2, kay na ay 1, 2. Diri sa D, 2. Sa C, kay 3 na. O sa B na 3. Sa C pod 3. So this is not Eulerian. However, na siya remark dira. Okay. Pag imuha daw connected graph na exactly 2 odd vertices, take note class, exactly 2 ra gyud. No? Exactly 2 pasabot duha ra gyud. Maka-form daw ka og Euler Path. Nga mag-start ug mag-end sa duha ka odd vertices. So mag-start sa isa ka odd vertex, then mag-end sa isa pa gyud ka odd vertex. No? So for example, let us mag-start daw. So pili lang ka aha ka mag-start kang B or kay C. So pwede ko moagi dito BA, AC, CB. So class ang Eulerian is ang Euler nga path or Euler nga circuit mag-agi ka once sa mga sa mga edges, pero pwede ka magbalik-balik sa mga vertex. Basta kay dili ka mo balik sa edge. So balik ta. So pwede ko mag-start kang B, padulong kang A, padulong kang C, padulong kang B, adudain ko kang D, balik ko kang C. So as you can see, naatay Euler path nga na form. Euler path lang siya. Kaya ang atong gi-form kay B, A, C, B, D, tapos C. No? So, nag-start siya sa isa ka add nga vertex, nag-end po siya sa the other add nga vertex. So, take note. Kini po, na po ni siya Euler nga circuit. Kaya ngunta, Eulerian graph maning. Kasi nga na to. Pwede ka agi dito, agi ka dito, agi na po ka. Or, kung kadumdum mo anang dula class ka na bitong, without lifting your pen, draw this. So, pwede ta, ano, no? Without lifting my pen, I will draw this or I will trace this. Kana, pwede ko agi dira, 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 dira. No? So, kinay ang internet kay wala niya. Okay, so kana akong kuan. Okay, so you can try it for yourself. Ma-download man yung PDF ani, no? Okay, then we have the answer. Let us which of the following graph has an Euler circuit? So to find an Euler circuit or to find if na siya Euler circuit, dapat even ang number of degrees sa tanan nga vertices. So, let's try. Diri pa lang 2. Pero diri na ay 3. Nge, na anay 3, dili na siya even. So, pasabot, dili ni siya mao ang answer. So, diri apod, diri pa lang gani na anay 3. So, dili pod ni siya, wala ni siya Euler circuit. Kini, 1, 2, diri pod, 2, diri, 2, diri, 2, and diri, 4 kabuok. No? So, pasabot, kini ang answer. There is an Euler circuit diri. So, this is an Eulerian graph. Eulerian graph. Okay. So, ang answer ani is letter C. Okay, the answer is letter C. Okay, so let's have an application. So the floor plan of the art gallery is pictured below. Draw a graph that represents the floor plan. Where vertices corresponds to the room. So pasabot ang mga rooms ang vertices and nag-adjust corresponds to doorways. So is it possible to take us through passes through every doorway without going to the same doorway twice? Okay. So para mahimuan na nato siya graph, himuan na to mga dots ang rooms. No? Kana. Tapos i-connect na to siya using the doorways. Kana. Na may doorway dira, na po diri, o diri, 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 na po doorway diri, na po doorway diri, and also here. So, muna siya atong mga vertex ang mga room. So, para mabalaan nato kung na ba siya, pwede ba nato siya maagian tanan doorways without taking murag dili ka pwede mo balik or going to the doorway twice. Atong i-check kung Eulerian siya. Di ba mo man ang Eulerian, no? So, para ma-check na tong Eulerian, tanaw na to ang degree sa kada vertex. So, diri aduha, diri 1, 1, 2, 3, 4. Diri 1, 2, 3. Oops, kini tulupod. Kini duha. Kini 1, 2, 3, 4, 5, 6. So, makaadto ka tanan nga naman kinakay duha ka add nga vertices. So, maagian daw na nimo tanan doorways pero dili ka makasugod ug makastart sa the same nga vertex. So, pwede na nimo agian tanan. So, na ang answer. So, this one. Okay. So, since two vertices are of odd degree, which is C3 and CD, and the rest of it are of even degree, thus the Euler theorem's remark, an Euler path exists, but not an Euler circuit. Therefore, we can pass through each doorway once, but we cannot return to the starting point. So let us start at a vertex with an odd degree, either room C or room D, by trial and error. So one such path is, pwede ka mag-start kang C, adto ka kang B, tapos F, E, D, C, F, D. So, kana daw. No? So, that's it for this, this topic. We have oil. Padayon ta. So, that's it for the Eulerian graphs. No? So, let's have the final topic na good. Or the last topic, which is kung na Eulerian nga circuit, napod tayo Hamiltonian nga circuit. Okay, so by the way, ang Iceberg problem, tanaw na to using the kadtong Eulerian circuit. So kung sa Iceberg problem, naman tayo 3 nga degree dire since na tayo 1, 2, 3. So 1, 2, 3, 4, 5. Dire pod 1, 2, 3. And this one atay 1, 2, 3. So dili gid siya Eulerian. So you can see kay add tanan ang iyahang degree. Okay. So ato ta sa Hamiltonian circuit. So again, remember nga ang ato ang Eulerian circuit is agian nato tanan edges exactly once. Tapos mo na siyang Euler path, no? Ang Euler circuit is agian nato tanan edge exactly once. Tapos mag-start ta og mag-end sa the same nga vertex. Okay. Ang Eulerian circuit, ang Eulerian graph is mag-contain siya or ang graph is Eulerian if mag-contain siya og Euler nga circuit. Okay. Okay, so Hamiltonian graph na punta ganina na Eulerian graph, karon Hamiltonian graph. Ang Eulerian graph is kadto lagi no, i-visit niya tanan edge. Kining Hamiltonian graph is i-visit niya tanan vertices, katong mga points. Bahalag dili niya maagian tanan edges. Basta kay ma-visit lang niya ang tanan vertex, katong mga points. Bahalag dili tanan maagian ang lines. Basta maagian tanan ang vertices. Okay, so nag-start ni siya kining Hamiltonian's nga graph by it is named by uh, uh, it is named kanang tungod ani ni Sir William Rowan Hamilton, who invented a puzzle game which involve hunting for a Hamiltonian cycle. So ang tawag sa game is a Gaussian game. So it was distributed as a dodecahedron graph with a hole at the vertex. So instead of ingon ani yang naong di ba dodecahedron katong murag cube nga na ay 12 faces, no? Nga ang kada face is kuan pentagon, no? 5 ka sides ang iyahang face tapos na ay 12 ka faces pagyot, no? So kung ato siyang himo a graph ingon ani iyang nawong, no? Mura siya gilatag ba? Okay, to solve the puzzle or win the game, one had to use pegs and string to find the Hamilton cycle and a closed loop that visited every hole exactly once. So iyahang i-visit tanan hole exactly once tapos mag-start siya og mag-end sa the same nga vertex. Okay, so ang Hamiltonian path is katong i-visit lagi niya exactly once ang kada vertex. Ang Hamilton circuit is i-visit niya kada vertex exactly once tapos mag-start siya og mag-end sa the same nga vertex. Ang graph is Hamiltonian if and only if makakita ta og Hamilton circuit sa iyaha. Okay? So, let us find Hamilton circuit here. So, for for graph 1, pwede ta maka-form og Hamilton circuit. Let's try. Pwede ta maagi kang A, B, C, D, E, A. So, that is a Hamilton circuit. Kaya na-visit naman niya ang kada vertex exactly once. So, that is okay. So, this is again a Hamilton circuit. Kana no? Kana. So, na kay A, nato ka kang B, kang C, kang D, and kang E. No? So, that is a Hamilton circuit. Diri sa pikas, if A, B, D, C, diri ako taman. Kaya di na ako pwede mo balik dito. Kamo balik na ako kang B. No? So, kini siya na siya Hamilton circuit. Diri na-visit niya tanan edges class. Pero wala niya na nakabalik sa starting point. Ay, edges, vertices di ay. Diri sa graph number 2, na-visit niya tanan vertices, pero wala siya kabalik sa iyang starting point. So, this is only a Hamilton path. So, A, B, D, C. Pwede pud ka A, B, C, D. Di na ka pwede mo balik. Pwede ragapon ngun ana. So, kini siya na lang siya Hamilton path. So, this one is, ang kining G1 is Hamiltonian graph ni. Kaya na siya Hamilton circuit. Again, Hamiltonian graph na siya, kay na siya Hamilton circuit. Kay diri sa pikas, kung gikan ko kang A, mato ko kang B, kang G, kang E, kang C, kang D. Dili na ako ma-visit si F, kay di man ko pwede mo balik padulong dito, no? Kay dili man siya pwede mo balik. Dapat kas aragid ka mo balik sa kada vertex. So, mangita taglaing dalan kung naabag yun or wala. So, let's try. Okay, kung diri po ka moagi kang A, kung diri ka moagi kang A, moadto ka kang B, moadto ka kang C, kang E, kang F, dili po ni moagian si G ug si D. Nga naman, kay mobalik, kinahanglan mo kang balik dito para makaadto ka dito. So, dili siya maka-form og Hamilton Path and Hamilton Circuit. No? So, diri si sa pikas, wala siya no Hamilton Path and Circuit. So, wala siya Hamilton Path, wapagid siya Hamilton Circuit. Okay, which of these figures, so muna siya tong tubag, no? So, sa graph 1, so nakakita tawag Hamilton Circuit. So, pasabot, it is a Hamilton graph. Okay, Hamiltonian graph. Okay, sa ikaduha, wala ta kakita og Hamiltonian circuit. So pasabot dili siya Hamiltonian nga graph. Pero nakakita tag Hamilton nga path. Sa ikatulo nga graph, wala gyud bisan isa. No, wala Hamilton path, wa pagi Hamilton circuit. Okay, so mo to yung gingon, G has a Hamilton circuit. Pwede ka A, B, D, E, A. So actually, dili unique ang imong makita nga circuit dira. Pwede ka A, B, C, D, E, A. Pwede po ka A, B, C, A, A, E, D, C, B, A. Pwede po nga na. Or pwede po A, C, D, E, B, A. The same naman gapon, imong na-visit tanan vertices. So sa graph number 2, wala siya Hamilton circuit, pero na siya Hamilton path. And ang ang graph 3, wala gyud. Okay, so mo ni siya ang dodecahedron. It is a polyhedron with 12 flat faces. So kung himo na to siya graph, ingon ani ang equivalent niya nga graph. So napakahay Hamiltonian Hamilton circuit dira. Let's try. So kung i-visit na ako sila tanan, kas araman daw no. Ana. Trapo ko dito. Ana. Dili na po ko. Okay, na-visit na ko tanan vertices. No? And naka-start og nag-end sa the same nga vertex. So, kining I-quotient game, pwede day siya ma-solve. Okay. So, unlike sa Eulerian graph nga naa siya'y theorem nga kung even tanan ang degree sa kada vertex, that is an Eulerian graph. Ang Hamilton circuit, wala siya'y ingon ana nga theorem. So, akong buhaton is trial and error kita. So, there are theorems nga naa pero dili siya applicable for all kinds of graph. So, munang wala na lang na magikuan diri. So, trial and error lang yun kung pwede ba or makakita ba ka Hamilton circuit. So, that's it for today. So, we have discussed brief history sa graph theory. We have terminologies sa graph theory. We also have Euler path, Eulerian graph, and we also have Hamiltonian graph. So, naputay mga recorded nga videos sa LMS. You can view the videos para basin mas ganahan mo ato compared ani akong gi-record. So, that's it. Just see you on Friday. Online lang gihapon ta. Okay? So, that's it, class. Bye!